In this video, I want to show how to find limits through basically changing the variable. So sometimes when we're solving limits, we get some uglier ones, and unfortunately rationalizing and factoring can't really help us out to determine what the limit actually is. So we have to take another route, which is we're going to plug in one variable for another in hopes of solving the thing. So to begin with, always make sure to check out your limits to see if they work out to the indeterminate form if you like. You can sort of tell. So 256, when plugging it into x under the radical, which is of the eighth, so eighth rooting it, I guess, that gives you 2. So 2 minus 2 in the numerator. 256 under this x radical 4, that would give you 4 minus 4, so that gives us an indeterminate value of 0 over 0. So we know we have to do some algebraic manipulation here. So the first thing would be, well, whenever you see something, whenever you see a square root basically greater than 2, so if you have a 3 and so on, then you know you might have to do some variable changing. So here's what I mean. What we're going to do is we're going to say let u equal x to the something. Now I say to the something because over here we have x to the 1/4, and here we have x to the 1/8, right? Just expressing it in terms of the exponent form. Now we want to have a common, like a common denominator for both of them. So for x, for 1 over 8 and 1 over 4, well, that would just be 1 over 8, right? So that would mean just multiplying this by 2. So I'm going to say let u equal to x to the 1 over 8. And if I were to square u, which means I would squaring u, which means multiplying this 1 over 8 here, that would give me x to the 1 over 4, right? Because 2, 4. That's what you end up getting. So I'm just going to erase all that. So basically, I've said let u equal to x to the 1 over 8, and let u squared equal to x to the 1 over 4. X to the 1 over 4. Now, the point of doing this is to obviously find us a more easier limit to solve. Now the next step would be to indicate what u is approaching. So we know that x here is approaching 256, but what is u approaching? So we write, as x approaches 256, u approaches what? Well, we can just look at this right here. U equals to x 1 over 8, 256, if you plug that into x 1 over 8, you end up just getting 2. You can try that in your calculator. So now we have sort of, we've basically defined another variable completely, and now we can use it to solve. So we can say this equals to the limit of u approaching 2. And at the top, we said u equals to x 1 over 8, so that just becomes u minus 2. At the bottom, we said x to the 1/4 is u squared, so u squared minus 4. We say equaling the limit u approaching 2. Now we see a u squared minus 4. This is a difference of squares in the denominator, so this becomes u minus 2, u plus 2, all over u minus 2. To the next line, u approaches 2. We see that after factoring this, we can cancel something out. This u minus 2 and this u minus 2 can get canceled out, so these go bye-bye. This becomes 1 over u plus 2. We plug in the 2 now. 2 plus 2 under 1, 1/4. And that is the limit that we have solved. You don't need to do anything else. You don't need to go back or change to x. We've completely just defined this limit in terms of x, now in terms of u, so that we can solve it. So that's it. We're done. We don't have to do anything else. Let's look at another example here. This one is a little more, maybe not as challenging, maybe a little bit more. So some basic idea, same idea here. We have x to the 1/3 right here, right? X to the 1/3, and here we just have x to the 1. A little bit easier. Now basically, we can just say, let u equal x to the 1/3. Because if we cube u, we just get x, because cubing this would mean this. So these 3's here cancel out, that becomes 1, therefore we get that. So we have now changed it in terms of u. Now we need to know what is u approaching as x is approaching 64. As x approaches 64, u approaches what? Well, we can put that in. So 64 under the cube root, well, that just gives us 4, right? And that makes sense because if we tried to just solve by just putting it in here, we would get 4 minus 4 over 64 minus 64 because we're saying as x approaches 64, which gives us 0 over 0. That's the indeterminate form. So obviously we need to do some things, which we are doing right now. So as x approaches to 64, u approaches to 4. That's it. Now we just put it all in terms of u. The limit of u approaching 4 equals to, we said u equals to x being cube rooted, so that's just, sorry, we said u equals to x being cube rooted, so that's u minus 4 in the numerator. In the denominator, we have u cubed minus 64. The limit, u approaches 4. Now, u cubed minus 64. What we can do here is use one of the things we might know, which is a cubed minus b cubed here. And so the idea we're going to apply is SOAP. So here's what that looks like. SOAP means same, opposite, always positive, and that's referring to the signs. So let's start with the denominator first. So we would have u minus 4, because we're trying to factor u cubed minus 64. Then we would have u squared, right? If you've forgotten the formula, it's a minus b, a squared plus ab plus b squared. That is the formula. So applying that into this thing, we have u minus 4, u squared. So same, because same as this negative sign here, same as this negative sign here, but opposite of negative sign is positive. Now we're going to just use u times 4, which is 4u, plus squaring 4 is 16. So let me just erase this mess here. Or maybe I should have written this a little lower. The limit, okay, u minus 4, u squared plus 4u plus 16 all over u minus 4. So equaling this, the limit of u approaching 4. We can see here the u minus 4 and the u minus 4 actually cancel out, which leaves us with u squared plus 4u plus 16 all over 1. Plugging in 4. 4 squared is 16. 4 times 4 is 16 plus 16 all over 1. And this ends up giving us 1 over 48. And we've solved that. So just some basic factoring after plugging in the different variable. Not too bad, hopefully. Let's go to our third example here. So we have the limit of this x plus 100 cube rooted minus 5 over x minus 25 as x is approaching 25. So in these ones, when you have like a big guy underneath the radical that is greater than the square root, you just make your life easy and you just say let u, generally speaking, equal x plus 100 under this cube root. Mainly because if you don't have any other thing, if you just have this, like if you just have a cube root and something else to the 1, like we have this x over here to the 1, then you can just do some algebraic manipulation to let x equal whatever u is supposed to be. So here's what I mean. Let u equal x plus 100 under the cube root. Now if I wanted to describe this in terms of x would equal to, well, we would have to cube this. So here, let me put an arrow there. In terms of x, so x equals to what? I would do this, well, I would cube a u here, and then cubing the left side and the right side would just give us x plus 100. And then rearranging for x, u cubed minus 100. So there you go. We can actually now plug this into this x right here. So not too bad. This question isn't too bad. So now that we've defined that for both things, now we have to say what is u approaching. As x approaches 25, u is approaching what? Pause the video and see if you can figure that out. So if we plug x approaching 25 in this, 25 plus 100 under the cube root, that's 125 under the cube root. And if you don't know, you can put this in your calculator. That just gives you 5. So therefore, u is approaching 5 because we have u equaling cube root of x plus 100. Now we can write this in terms of u. The limit of u approaching 5, x plus 100 cube root is defined as u minus 5. In the bottom, x equals to u cubed minus 100, u cubed minus 100 minus 25 in the denominator. Simplifying this out. In the bottom, you're getting u cubed minus 125, u minus 5 at the top. Now, same idea in the last question. We see we have a cube, like a cube sort of difference thing going on. I forgot the name of it, where it's like a cubed minus b cubed. So we're going to apply that same formula here again. And we're applying SOAP, which is the acronym to remember. Same, opposite, always positive in terms of the sign. So we're going to have the limit u approaching 5. So I'll write this out again. A cubed minus b cubed is a minus 5. Same. All right. Opposite, always positive. Okay. So now at the bottom I have u minus 5. Same. U squared opposite. So 5 plus u. And then always positive here, which is 25. All over u minus 5. These guys cancel out. And we plug in 5 into this denominator here. So 5 squared is 25 plus 25 plus 25 all over 1. That's 3/4, so that's 75. 1 over 75. And that's that. One more. Oops. Let's just do one more. One last one. Pause the video and see if you could figure this out. All right, so we've got a funky one. We have x to the 1/4 here, x to the 1/12 here. The same idea as the first question is we want to find like a common denominator, right? It's almost as if we're adding the fractions. So the common guy here would be 1 over 12. So we're going to say let u equal x 1 over 12. Now if I wanted to let some variable u equal to x to the 1 over 4th, I would simply just cube u. Because if I multiply u by 3, if I cube u by if I cube u by 3, if I cube u, then I'm multiplying this exponent by 3, so that becomes 3 over 12, or I can just say simplify this 3, 12 divided by 3, 4, right? Basic idea. So that's basically it. So we've set ourselves up the variable. Now we have to define it as x is approaching, or as u is approaching, I should say. As x approaches 1, u approaches what? Pause the video and see if you can figure that out. Okay, so good thing about 1 is you could do it to the whatever. It's still going to give you 1, right? 1 times 1, 1 to the whatever. So as x is approaching 1, u is approaching 1. So we just plug that all in. The limit of u approaching 1, root, so x to the 1/4 is defined as u cubed here. So we have u cubed minus 1. And then x to the 1 over 12 is defined as u minus 1. Now we have another SOAP situation here. So hopefully you've mastered this by now. I'm just going to go brazy here. So all I've done is same, opposite, always positive. Same, opposite, always positive, right? U minus 1. These guys cancel out. I ultimately end up getting limit as u is approaching to 1 for u squared plus u plus, is that a what? I wrote like a b, 1, and then we just plug in 1, so u 1 squared is 1, u 1, 1, 1, there's the 1, 1 plus 1 plus 1, which gives us 3. That's it. That's the last one, figured it out. So yeah, it was a little repetitive in terms of SOAP, I guess, but that's basically the idea of just letting one variable equal another variable and solving it. It makes your life easier. You don't have to change it back to x. There's no point in doing that in the middle of your steps. You're just basically describing the limit in another way that's still the same thing. So hopefully this helped. Let me know in the comments, yeah, if this helped, and yep, I shall see you in the next one.